Okie dokie, artichoke. We are on to number 6 from our practice test. All right. Now, in this case, we are using a little bit of synthesis of the last 2 questions. All right. So we identified reaction types in number 4. How do we use the type of reaction that it looks like it ought to be to predict what the products should be, right? And then write the correct formulas for those products. All right, so number 6A, it looks like we have one element by itself, and we'll call that A, and then 2 elements together, hydrogen and chlorine, as B, C. This is like an A plus BC reaction, which you should recognize if you've done your work as a single replacement, which means our calcium and hydrogen, our cations, are going to swap spots. All right. Now, calcium is a +2. Chloride is a 1 minus. So when those combine, it's going to be CaCl2. I'm not going to review that again. Go back and watch those other videos on basic ionic bonding if you want to know why I put a 2 there. All right. And we're going to be left with hydrogen by itself. Hydrogen being a Brinkerhoff element does require a little 2 next to it because it is diatomic when it's by itself. Okay, and again, I'll say this perhaps one more time. If you still don't know how to write formulas, right? Why is that written as CaCl2? Why do I know to put that 2 there? Go back to the Unit 4 topics with links posted in the same slide you got this link from, all right? And there is some basic ionic bonding review. You need to go back and watch that and get that figured out, right? The reason this 2 is there is stuff we talked about in class. It's one of the 7 diatomic elements. If that's not in your notes, shame on you. You can ask Mr. Huderberg about that the next time you see it. All right. Letter B, we got methane is what that is, by the way. You may not know that name, but that's a carbon with hydrogen, so it's a hydrocarbon plus oxygen. That tells me this is a combustion reaction, which means I know the products are going to be carbon dioxide and water, because that's always the products of the type of combustion reactions we do in this class. So easy peasy. We don't have to balance, right? Not required in this case. Okay. Now, here we've got silver nitrate. So this is an A, B together, plus aluminum chloride, which is a C, D together. All right. So that means I would predict this as a double replacement, which means I'm going to have Cb plus Ad on this side. Okay. So in order to, this would be a double replacement. Okay, reaction here. So I'm going to put aluminum, which is C, with nitrate. Now, in order to properly combine those, I need to know that aluminum is a +3 and nitrate is a -1 or 1 minus. Okay, which means I need to add the subscript 3 to the nitrate. Okay. Not talking about that 3. Oh, I'm getting back into that. Go back and watch those videos if you don't know how to do this, but this is going to be A, L, parentheses, NO3. 3 plus A and D combined, which is silver with chloride. Those are both 1s, so it's just AgCl. That's the way that looks. So your final answer, you don't need to have this up there. That's just kind of making things messy. Right? Don't really need to have that either. That is our final product there. What we would expect in a double replacement reaction. Now here we have fluorine by itself. So just A plus B, C. Now, this looks like it's going to be a single replacement reaction, but we have to recognize that fluorine is an anion, or, going to have a negative charge. So a negative ion will always replace another negative ion. So in this case, we're going to go yields Ba plus C by itself. So slightly different here, because calcium is a positive ion, So it's going to replace hydrogen, which acts as a positive ion there. Fluorine's a negative ion, so it will replace chlorine, which is also a negative ion. And my formula should be NaF plus Cl2. And again, that 2 goes there because chlorine is one of the Birkhoff elements.